and welcome to the program. I'm Carl Pauls. This is the Ecomodernist channel live. I'm here with Chris Bergen and our special guest. Darryl Siemer is here to speak with us. Darryl has a PhD in analytical chemistry and worked at the Idaho National Labs for years performing research and publishing papers about analytical chemistry relating to nuclear fuel reprocessing and nuclear processes and waste streams. He later worked at the INL Engineering Lab pursuing the chemical aspects of fuel reprocessing and waste management. Welcome to the program, Darryl.
Yes.
You've got this book. It is titled A Nuclear-Powered Green New Deal, and it has a very provocative subtitle, An Ex-Insider's Explanation of Why the U.S. Sorely Needs but Hasn't Implemented One. Tell us about that.
In 2006, it was when the new contractor came in with the site was given a new mission. The new mission was, of course, just to develop a nuclear renaissance that made sense. And I was still working and had spent the last few years going back and forth about the approach they were proposing for their treating the reprocessing waste. I was still working and had spent the last few years going back and forth about the approach they were proposing for their treating the reprocessing waste. It didn't make any sense then, and they went ahead with it anyhow. This is right after the Manhattan Project closed up. I mean, they started out there, I think it was 1949, and by 1951, they got their first reactor going, which was a breeder reactor, thank God. It actually worked and it made sense. In those days, most of the research was done for a real reason, and it was done quickly. Then tested something like 52 or 54 reactors. That was mostly over with by the time I got there in '78. So we tested metallic fueled reactors, oxide fueled reactors. I think it did some nitrile fueled reactors, and they had some graphite fueled reactors. So that was the unique thing about this facility. It wasn't a production facility in that, we didn't have reactors on site that were producing massive amounts of plutonium. So one of the problems that the lead lab is having right now is that it hasn't dealt with its own waste. If you're really actually going to solve the world's problems, you're going to have to do it with some kind of breeder reactor, which is going to require reprocessing, which is going to require waste management. Now, we haven't really managed our waste. That's a real problem. The outside world always brings up the waste issue, and they have reasons for doing it. It's the way the system works. It's a study system. They're in the study business. They're not in the solution business.
So if we change the mission of these labs, the mission of whoever's in charge of nuclear development, what kind of program could we have produced, and how much is it going to cost? Cost is not something I can deal with, okay? We can make anything cost infinite amounts of money. If you look at what we've accomplished, you take what we spent and divide what we've accomplished into it, it's an infinite number, okay? So I'm not going to guess at what it's going to cost. I do know that, for instance, in terms of building reactors, Korea builds them for about now between $3 and $4 a watt. Okay, the last time we built a reactor here was like $15 a watt. And that's just not competitive. And I'm not talking about exotic reactors either. I'm talking about boiling water or PWRs. We've been making those darn things since the 50s. Okay, it's just that we pile so much overhead on everything that we crippled ourselves. Now, China hasn't crippled itself. Russia has never been rich enough to cripple itself. And it's possible to solve these problems. The idea that we're going to solve the environmental problems, the energy, our environmental problems are related to our energy problems with tiny reactors that only consume U-235 is phony. It's wrong. A little bit of ballparking will convince anybody that bothers to do a little bit of math, and that's easy to do with modern spreadsheets. That's not going to solve the problem. So we have to go to breeders. Now, do we need to come up with new breeders to do that? No, we don't. The Russians have been running the BN 600 now for about 45 years, and they're 800 for what, 15 years or something like that. These are breeder reactors. We know how to do it. They know how to do it.
Mhm.
The French knew how to do it. We're not doing it because it doesn't fit the business model. It's the contractors. Well, right now it's the nuclear industry. They don't want to change anything. It's one of the reasons why all these small modular reactors are talking about now are much bigger than they should be. Because they don't have to change the fuel very often. See, you're going to put the fuel in and walk away for 5 years or 10 years or however long, sounds good to whoever's owning the thing. They don't have to bother with actually doing anything. All they want is a black box, and they want it as simple and cheap as possible. So, in my opinion, the only way we're actually going to solve this problem is to start over from scratch, and that is have somebody like General Groves or the Admiral take charge of it. So we're going to do it. And we don't have to reinvent the wheel to do it. We'll just bribe one of them really smart Russians to come over here and he'll do it for us. At least he'll tell us what to do. And maybe we can get our new friends, the Chinese, who actually can do things in large, efficiently, to do it for us. So instead of fighting the Russians and fighting the Chinese, why don't we get together and solve the world's problems? That's the real problem. It is political.
Yeah.
And this country is almost as bad as Germany in that respect.
Yeah. Is any of the math, in terms of the economics, is that something you track?
I can certainly explain why electricity costs are going up. We don't need to spend that kind of resources on developing reactors that are only good for powering, more servers. We just shouldn't be doing it, but that's where the money is, see? So that's the direction they're going. So what do they want? They don't care about all they want is cheap power. Well, they want reliable power. And that's the problem with wind and solar is it's not reliable, and batteries are too damned expensive. You cannot run a modern industrial society with batteries. You just can't do it because at least charged the way that they are, through renewables. So that the real mission of the site, it should be at all sites, and I think whoever's in charge of this should be to render nuclear power renewable, which is fairly easy to do. As far as dealing with its waste is concerned, vitrification makes all kinds of sense. If you reprocess in a sensible fashion, it's easy to do. The problem is that most of the things that we set out to do, we don't approach in a reasonable fashion. So we end up not solving the problems when the answers are right there in front of us. We know how to do this. We know how to make reactors work. We know how to vitrify things, and we know what the real problem is. It's not that there isn't enough AI. There is plenty of AI. But we need to address the real issues, and that is coming up with something that's affordable, that's clean enough, so we can replace fossil fuels. That's what needs to happen. To do that, we've got to change how we go about doing things.
I was going to say you talked about the massive complexity of the chemical process that you were being directed.
It's not that complicated.
Well, the process where you have to separate every little element. What are you going to target?
You want to keep the americium because it's useful for things. Okay, that's what your smoke detectors are. But you don't need that much for smoke detectors. And as far as going through when you reprocess this fuel, getting uranium and plutonium and neptunium, we know how to do that. The French knew how to do that. The Russians know how to do that. And we used to actually be able to do it. Right now, we can't seem to do anything. But yeah, if you do that, then it becomes a very simple process. Simpler than it used to be. Now, if we were reprocessing in a reprocessing facility, and we're going to put the fuel, put it back into the reactor, we don't have to get it very clean. Meaning that the separation is simpler than it used to be, not more difficult. And all we need to get are the easy things that you can get with well-established techniques. Reprocessing would be simpler, not more complex. It's the idea that we have to separate in one place and ship to another place, and everybody is touching it and fooling around with it. That's the issue, and a chain of command that actually works.
So every plant could have its own fuel reprocessing building right next to that reactor.
Well, several. Frankly, there ought to be clusters of reactors. Each site should be a cluster, at least 2, and maybe as many as 6 reactors, and a reprocessing facility next to them that handle them all. So we're not shipping stuff all over hell. Okay, there's no real reason to do that. There are reasons to have small reactors, especially hot reactors for niche applications, for the production of power. No, yeah, breeders make all kinds of sense because they're sustainable. Sustainable equals renewable.
Mm-hmm.
And I don't understand why the industry doesn't seem to realize it and insist that, the decision makers and the advisory groups, and they should be insisting that it become renewable. Then nuclear power would be a good sell. Right now, it's pretty hard to sell. It can't seem to deal with its own waste problems, and it's not renewable. Because if you look hard at this, if we're going to power the world with nuclear reactors, we've run through all of their uranium that the nuclear industry says it could get if they worked really hard at it, which is, depending on which red book you look at, it's from 6 million tons up to about 18 million tons. And that's a real stretch on the 18. You'd go through that in just a few years if you tried to power the world with non-breeder type reactors. Okay, you've got to go to a system that actually can use the fertile that's in the world. And that's the U-238. And of course, there's 3 times as much thorium. Okay, that's what needs to happen. And it needs to happen in a way that actually gets it done. It's not a study project. The way the Department of Energy goes at every project is it is something to study. And so one of the first things you do when you get a project in the DOE system is come up with some reason why you have to study stuff, even though you don't have to study it.
Right. If the cost of seawater extraction comes down, what's your take on that?
It's pie in the sky.
Is that the complexity of the process, or is it?
No, it's the sheer magnitude.
Okay.
First of all, every paper you and presentation that you hear, when you listen to or watch, starts off with a falsehood. That falsehood is that there's, let's see, 10,000 times as much uranium in the ocean as there is in the crust of the Earth, which is totally wrong, okay? It's the other way around. The crust of the Earth is bigger than the oceans, and the crust of the Earth averages 3 parts per million, and the ocean averages 3 parts per billion, okay? The difference between million and billion is fairly substantial, and the crust of the Earth is a hell of a lot bigger than the oceans. And this is the kind of stuff that you see all the way through these things. The country that's actually looked at this very seriously is Japan. Japan put a hell of a lot of effort into actually testing some of these seawater extraction systems. And bottom line is, it's impossibly large. You can't do it, and provide the amount of uranium that trying to power the world with non-breeder type reactors would require. It's just impossible. Each gigawatt a year's worth of power generated by a non-breeder reactor requires, if you look at the statistics, over 200 tons of brand new uranium, fresh uranium out of the earth. Okay? And if you try to run 22,000, this is what it would require. If we were to power everybody in AD 2100, the UN's best guess of the population of the world in 2100 is 11 billion people. If you were to power them at the half the primary energy that we here in the United States use, we would go through all of that. Can you get that much uranium out of the ocean with these filters? No, you can't. You'd have to surround every country. You'd have gigantic kelp beds You know, essentially artificial kelp beds floating just offshore or wherever the current is high enough so that the water, you have to have moving water too. It's got to be moving.
Yep.
It's got to be bottom anchored, and it's got to be in there where the water can get around and soak up in these absorbents. And a little bit of math, again, I'm a technical nerd and I believe in numbers. And you can easily go from what the Japanese actually demonstrated and say, what, there just isn't enough places to do this anyhow. Now, if you were to use a breeder reactor and you're anywhere close to the ocean, you got to cool the reactor. You're pulling seawater out of the ocean to do that. Okay, breeder reactor doesn't require nearly as much. And you've got water moving already that you've cleaned up to the point that it could go through these filters. So a breeder reactor you could feed a breeder reactor. And in fact, several breeder reactors, just the cooling water required to cool the damn things. That makes sense, but it doesn't make sense to go ahead and try to power a PWR or BWR or anything that has a similar fuel inefficiency that way. Okay, so that's pie in the sky. They depend on people not checking, getting down out with their calculators and doing a little math. They get away with it because almost nobody does that.
11 billion people, half of the per capita U.S. population, and that's 12,000 reactors. That's 100% nuclear, replacing all fossil fuels and no other resources. What's sort of the difference between a nuclear only and all of the above? Why can't we add, 75% wind and solar to supplement nuclear?
Well, let's say you're running a society that's got factories in it. Okay, and a factory, if it's only going to run half the time, the fraction of the time that the solar panel works where I live now in Iowa is about 20%. Okay, so 80% of the time you're not getting power to your factory with solar panels. Okay, the wind is more reliable. That's about 35% of the time. So 65% of the time you're not getting power to your factory. Okay, that means if you're actually going to run a society that does require, some efficiency in terms of doing stuff, you need reliable power. You don't get reliable power that, with windmills and solar panels. Okay, so what are you going to do? You're going to come up with gigantic batteries. You know what a battery costs for let's say a Tesla 3? Okay,
it's at least
like $12,000.
Yeah.
Okay, and how much is that? It's 80 kilowatt hours. That's all it is. Any kind of factory will suck that out. It'll be gone in seconds. You try to run a farm tractor with a battery. You'd be using about 20 Tesla 3 batteries to do 10 hours worth of rather light farm work with a tractor if you tried to do it with batteries. Okay, now I know batteries will get better and they'll get cheaper. They're not going to get that cheap. You need reliable power one way or the other. Now, if we got plenty of power, we can make like fuel for tractors using stover, leftover corn stalks and stuff like that by hydrogenating and make enough fuel to run those transportation related things like aircrafts and farm tractors and things like that with hydrogenated stover. You can do that. Reliable power to run the electrolyzers to make the hydrogen. Okay, so you need lots of reactors. Half as much as we're using now is 22,000 reactors for 11,000 people. That's a lot of reactors, but it's definitely possible. But we should have gotten started on this, but we didn't. And we're still kicking the ball down the road and pretending we're going to do it with little tiny reactors, and the smaller the better, it seems.
Is this what you call the nuclear renaissance, where we just go all in and start
Yes.
building nuclear? So
Yes, that's what it would take.
Tell us about this plan. What's the I see transportation, ocean acidification, carbon sequestration. These are the things that a nuclear renaissance addresses?
Well, yeah, we don't have to sequester that very much carbon if we don't, turn carbon into CO2. And that's why one of the reasons, of course, for doing this is that, of course, Texans would never admit this, but there is a finite amount of oil in the ground. Coal is really, really dirty. So we got natural gas. How long does a freshly fracked, you put a hole in the ground and you start sucking natural gas up? How long does that last? Well, it spurts out really well for a little while, and a year or so, and then you have to drill a new hole. You look at my home state of North Dakota, it's got like 17,000 of these. They're about 5 acres each, sites all over the place where they've kept drilling these holes to get, they get some oil out of it and they get some gas out of it. But the fact is you do suck these things dry. So we are going to run out of fossil fuels, and it's going to come sooner or later. It looks like it's going to be fairly soon because we're not coming up with a practical alternative to them. Nuclear power could be that alternative, but it doesn't look like it's going to be. For some applications, wind makes all kinds of sense. I think for individual homeowners, if he's rich enough and doesn't have too many trees around the place, he could get by with a bunch of solar panels and whatever power generated from windmills, because you can charge your car. If you've got an EV, it's got a nice big battery in it. You can charge your car with that. And if it were properly designed, you could, if you had to, you could suck out of your car battery into your house for emergency purposes. But you couldn't run a factory that way. Okay, you couldn't make the solar panels with that kind of energy. You could live in a home that's properly insulated with that sort of energy. But society as a whole has to have reliable energy. It's got to have a lot of it. And we will run out of fossil fuels.
I want to get quickly through this last important question.
Sure.
Your book goes into a lot of different designs for nuclear reactors. Tell us your favorites. What's the ones that you're really excited about?
I'm most excited about the BN800, the Russian breeder reactor that's actually a breeder. Right now, they're actually using MOX in the darn thing, so they're operating it with a closed fuel cycle, which is really wonderful. So that's my favorite reactor. It could be a sustainable reactor. Let's say liquid metal fast type reactor, any way you can, and actually doing it in a way that's commercially acceptable is a good start. It's not the finish though, but once you got to, in order to finish, you got to start. So that's the way I'd start.
Wonderful. Tell us more about your book. Where can we find it? Any final thoughts?
Okay. Well, I'll tell you what, it's a work in progress, as is, I'm writing another book. It's a cookbook, but it's about half rants about nuclear power and a bunch of other things. Seriously want to learn about this stuff and look at my books. They're free. My internet address is d.siemer@hotmail.com. You can have either or both books for nothing. This is a hobby and it's fun anyhow. In fact, they're both works in progress.
Yep, got it.
Great.
So I hope that everyone who's interested will get in touch, and I hope that we catch up to your ideas soon. This has been the Ecomodernist Channel Live. I'm Carl Pauls. You can find us right here on YouTube at youtube.com/@Ecomodernist1 or the Ecomodernist Channel. Please support us on Patreon at the Ecomodernist Channel. You can also find us on Facebook at the Ecomodernist Society of North America and on the web at esna.earth. That's esna.earth. I rebroadcast to some of my own personal channels on my LinkedIn at Carl Alex Pauls, on Twitch at Soyaddle, and at soyaddle.tv, among other places. And remember, emissions first, peace and justice will follow.
Please subscribe to us on YouTube, Ecomodernist Channel. Also to subscribe to us on Twitter and Facebook, Ecomodernist Society of North America.
And online at https://esna.earth.